Welcome to part 2 of our trig inverse review. In this video, we're going to be covering problems 8, 9, 10, 11, and 12. So this is, I'm not writing, did that the other time too, which was literally just 10 minutes ago. This is review part 2. So let's get started with problem number 8. So problem number 8 is tangent of x plus 1 is equal to 0. I'm going to subtract 1 on both sides and take tangent inverse of both sides. So at what angle is my tangent inverse, or my y value over my x value? -1. And that happens at two different places. That's going to happen at 3 pi over 4 and 7 pi over 4. And that's the whole problem. Put your answer in a solution set for your communication, and you are good. Whew, that was a fast one. That's probably the fastest one we're going to go through, because the next 4 are a little bit weighty, a little bit hefty, but you can do it. I know you can. So let's take a look at problem number 9. Move this up just a little bit. Problem number 9, we have 3 secant squared x minus 4 is equal to 0. Let's see what we can do. So first we're going to add 4 to both sides, and divide both sides by 3. Next piece is very, very important. In order to get rid of the square, we must square root both sides, and we end up with secant of x is equal to plus or minus the square root of 4 over 3. Please do not forget that plus or minus. That is so important, or else you're going to lose half your answers. But let's simplify what we can. So this becomes plus or minus square root of 4 over square root of 3. And we all know square root of 4 is 2, so this becomes plus or minus of 2 over square root of 3. Now, we can go through and rationalize this, but I wouldn't do that just yet, because what we really have is, wasn't holding the iPad, I was getting a little shaky. Secant is equal to plus or minus, that's an equal sign. There we go. Boop. Is equal to plus or minus 2 over the square root of 3. Now, just like we did for problem number, I believe it was 7 in the previous video where we were looking at cosecant, we know secant is the same as 1 over cosine of x. And what I can do is, if I flip both of these problems, which is something you're allowed to do, this goes back to ratio relations, we end up with cosine of x over 1, but you don't have to include that part, is equal to the positive and negative version of the square root of 3 over 2. So what you can do at this time, you don't have to, but what you can do is separate this out into two separate problems of cosine of x is equal to positive square root of 3 over 2, and cosine of x is equal to negative square root of 3 over 2. So I'm going to use cosine inverse for both of these equations. Oops. For the positive versions, your angle, at which angle is the x value root 3 over 2? That is going to happen at pi over 6 and 11 pi over 6. And for your negative version, where is it negative square root of 3 over 2? It's going to be 5 pi over 6 and 7 pi over 6. But don't end it here. Please make sure that you put all of your answers into a solution set in order from least to greatest. So this will be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So this is how to do problem number 9. Let's keep going. So for our next problem, problem number 10, this is cosecant squared x minus 2 is equal to 0. I'm going to add 2 to both sides. I'm going to square root both sides, I'm going to end up with cosecant of x is equal to the positive and negative version, please do not forget, square root of 2. And then I'm going to be doing the exact same thing here that we did in the previous problem. I'm going to change this to 1 over sine of x is equal to the positive and negative version of square root of 2. And I'm just going to stick that over 1. I'm going to switch these around. So we end up with sine of x is equal to plus or minus 1 over the square root of 2. But there's an issue here. We must rationalize. So let's multiply top and bottom by square root of 2. And we end up with positive and negative version of square root of 2 over 2. And now I feel much more comfortable that it's something that I recognize a little bit more. So what we have is sine of x is equal to the square root of 2 over 2. And sine of x is equal to the negative square root of 2 over 2. So I'm going to use sine inverse for both of these problems to get x by itself. And for my positive side, at what angle? Angles are my y values, root 2 over 2. That is going to get me pi over 4. Oops. There we go. And 3 pi over 4. And for my negative side, that is going to give me 5 pi over 4 and 7 pi over 4. So when I put this all together into a solution set, my answer should be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Just 2 more problems to go. Thank you for sticking with me. Let's see, that was number 10. Number 11 is next. So let's see. So for problem number 11, we have 2 sine squared 2x is equal to 1. Now, I'm going to let you know right now, this problem has 8 answers. Bear with me. You can get through this. First thing I'm going to do is I'm going to divide both sides by 2. I'm then going to square root both sides. And I should change my pen color. And we should end up with sine of 2x is equal to plus or minus square root of 1 over 2. This is plus or minus square root of 1 over square root of 2. Just plus or minus 1 over square root of 2. I'm going to rationalize this, multiply both sides, or both top and bottom, by square root of 2. And it's going to get plus or minus root 2 over 2. So we end up with sine of 2x is equal to positive root 2 over 2. And sine of 2x is equal to negative root 2 over 2. So you may look at this and maybe like, Miss Twain, I'm having some deja vu. Isn't that kind of like what we did right up here? Haha, it's a lightsaber, yeah. Isn't that what we have right here essentially? Yes, but the only difference is now we have this double angle, so we're going to go even farther. So all 4 of these answers we have from the problem up above are going to be 4 out of our 8 solutions, which is why I said this wasn't too bad. So let's take a look. So for our both these equations, we're going to use sine inverse. So we'll have 2x is equal to sine inverse of root 2 over 2, and 2x is equal to sine inverse of negative root 2 over 2. So when we're going through here, we need to keep in mind the double angle. So that's what this 2 is right here. How do I make this go away? There we go. This is a double angle, which means that we're going 2 full times around the unit circle. So when we find our answers here, we're going to go with our answers that were in our previous problem. So we can say that 2x is equal to pi over 4 and 3 pi over 4. But we still have to go around the unit circle again, and you can do that by adding 2 pi. So if I take pi over 4 and I add 2 pi to it, I get 9 pi over 4. If I take 3 pi over 4, add 2 pi to it, I get 11 pi over 4. So these are all the times, these are all the angles where my y value is root 2 over 2 for 2 full rotations. I'm going to do the exact same thing for the negative side. So 2x is equal to 5 pi over 4 and 7 pi over 4, but you're also going to get 13 pi over 4 as well as 15 pi over 4. So this is where you get your 8 answers. But we're not done yet. We can't put these into a solution set because we still need to deal with these 2's. You can either multiply everything by 1/2 or divide everything by 2. I'm just going to multiply everything by 1/2. Oops, I don't know what just happened. There we go. Just going to multiply it all by 1/2 for all of these so we can get the x by itself. And we should end up with x is equal to pi over 8, 3 pi over 8, 9 pi over 8, and 11 pi over 8 for our positive side. And for our negative side, we're going to get x is equal to 5 pi over 8, 7 pi over 8, 13 pi over 8, and 15 pi over 8. But again, not done, because we still need to put it into a solution set for our proper answer, and that's going to be pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8, 9 pi over 8. Ooh, 8 is just becoming a really weird word now. 11 pi over 8. Ooh, I don't know why I did that, because we're not done. 13 pi over 8, and 15 pi over 8. So these are all of our official answers, and you will notice that our final answers in the solution set are in fact still between 0 and 2 pi. So if you thought that one was crazy, wait till you get a load of our next one that in fact has 12 answers. It has 12 answers. It also happens to be problem number 12. So for problem number 12, this one's going to go crazy because it's a triple angle. We have tangent squared of 3x is equal to 3. So when I'm solving this one, first thing I got to do, take the square root, and we end up with tangent of 3x is equal to the positive and negative version of the square root of 3. So I can really write this as two separate problems. I can write this as tangent of 3x is equal to positive square root of 3, and tangent of 3x is equal to negative square root of 3. So for both of these, I'm going to use tangent inverse on both sides. X is equal to tangent inverse of negative square root of 3. Okay, so we're here. So now we have to ask ourselves at what angles is our tangent inverse, or our y over our x, square root of 3. So when I take a look at this, I'm going to say, okay, this happens in two spots. That happens in pi over 3 and 4 pi over 3. But we're not just looking at x, we're looking at 3x. This is our triple angle, so we need to go 3 times around the unit circle. So this is also going to work for 7 pi over 3, 10 pi over 3, 13 pi over 3, and 16 pi over 3. And a way you can think about it is like, okay, this is our first round around the unit circle. This is from our second curve around the unit circle. And this is from the third one. So this is how we're getting so many answers. It's because we have a triple angle and we're going around 3 times. And we're going to be doing the exact same thing for the negative one. So for our first past the unit circle, we have the angle that has your y value over your x value, or your tangent, at negative root 3 over 2 is going to be 2 pi over 3 and 5 pi over 3. So that's from the first round of the unit circle. You get 8 pi over 3 and 11 pi over 3 from the second round, and 14 pi over 3 and 17 pi over 3 from the third round. So again, this is where we get all of our answers. So from here, we're still not done because we need to get x by itself. So you can either divide everything by 3 or multiply everything by 1/3. I'm not going to show the step for this because that kind of got messy. But this becomes x is equal to pi over 9 times 4 pi over 9. Or sorry, not times. 4 pi over 9, 7 pi over 9, 10 pi over 9, 13 pi over 9, and 16 pi over 9. For the negative side, you're going to get 2 pi over 9, 5 pi over 9, 8 pi over 9, that's a 9, whoops, sorry, 11 pi over 9, 14 pi over 9, and 17 pi over 9. So we're going to make a really long solution set when we put all this together. From least to greatest, pi over 9, 2 pi over 9, 4 pi over 9, 5 pi over 9, that's a 7, pi over 9, 8 pi over 9, 10 pi over 9, 11 pi over 9, 13 pi over 9. Oh, I don't think I gave myself enough space. 16 pi over 9. Oh, I think I just did. 17 pi over 9. Okay. Whew. And those are the answers to problem number 12. I think that was one of the hardest problems on here, or at least longest problems on here. So thank you for sticking with me. Please go to the next video to watch the last problems of the review packet get done.